Well, good morning, students. Today is the 20th of April, 2020, the start of term 1. And this is your first lecture. And we are testing everything possible to see how best you can learn under these circumstances. I hope you are all okay and well and soldiering on in these very trying circumstances. And like I said in some of the messages that I've sent to you, if you have any difficulties, please do send me an email or even try and phone me, because the idea is to make sure that you learn as much as possible and you complete your studies. So today's lecture, therefore, I'll start on Unit 4, which is on perimeter and area of two-dimensional shapes. We have discussed this really to some degree, but I would like to just recap what I think is critical, and what I decided is just to go over it again. And also remember, this lecture will be recorded and to be sent to you as well, so just try and pay as much attention as you possibly can. And if you had printed your learning guide, this is on page 64 of your learning guide. That's where Unit 4 is. So then, Unit 4 talks about perimeter and area. Now, as teachers to be, your provision of actual definitions of the terms to your children is very critical. So then let's start with the term perimeter. Perimeter really means the distance around any two-dimensional shape. Now, so we can talk about perimeters of regular shapes. Now, regular shapes really are shapes whose dimensions are very clear, and we can know the length and the breadth quite easily. So this is a rectangular shape, and it's quite easy for us to know the length and the breadth, and therefore we can find the distance around it, which would be its perimeter. The distance around it would be its perimeter. Now, it is also possible that we can have a distance around a shape that is irregular. This is a regular shape. An irregular shape would be a shape that is probably something like that, which really is a shape, but we can find its perimeter. That would mean the distance around it, And when you are talking to children, it's important that they understand it from this point, that perimeter really means distance around. So it can be around a regular shape, and it can also be around an irregular shape. So try and provide examples in your class that show what you mean by perimeter. So ask your children, now children, show me perimeter of any shape that that is in front of you. So they can show you the perimeter around a book. They can show you the perimeter around their table. They can show you the perimeter around the classroom. So try and make sure that your lessons reflect the environment around which the children are. So, therefore, start probably by talking about a perimeter of an irregular shape, and the smart kids will probably ask you, but ma'am or sir, how do we find perimeter around this? It's true. Now, the best approach really around an irregular shape, it's either to have a rope around it. If you were to run a rope around here, like that. So if we started from there and ran a rope around it like that. So what we would do with this rope, therefore, would be now, after we've gone around it, we now straighten the rope. We put it on a straight line like that, and then put a ruler. The ruler might go up to there. And then maybe this is 10 centimeters, 20, 30, 40, 50, and maybe that's 55. And therefore, it's 10, 20, 30, 40, 50. So this might be maybe 51. So we would know that from there to there, the length of the piece of prop that went around our shape, which is the perimeter, is say 52 centimeters. So we would say the perimeter of this an irregular shape is therefore 54 centimeters. So that's how we measure an irregular shape, which would be good illustration. And if you are dealing with really much younger children, you'd therefore let them do that as a class exercise. They cut different shapes and try and measure, they play with a rope and so on. The idea is for you to make them understand the meaning of the statement, of the term perimeter, which means the distance around. So let's now look at perimeters of regular shapes. So let me use a better color. So the regular shapes that we talk about mainly is, excuse my drawing is not so good. Right. So this is maybe a rectangle. This will have length and this will be breadth, L and B. Perimeter would be the distance around. So that means this would be L, that would be B, this would be L, that would be B. So perimeter of a rectangle, therefore, would be L plus B plus L plus B. If we put the likely terms to one side, this would be 2L plus 2B. 2L plus 2B therefore gives us, we can factorize, remember that term? We can factorize the 2, take the 2 out, there will be left with L plus B, close brackets. And again, remember this is in units. We don't know what the units are, we just write units. But if it was in centimeters, it would be centimeters and so on. Now, let us try and provide the units. So, if L, therefore, was, say, 10 centimeters, and B was, say, 5 centimeters, our perimeter would be 2L plus B, which would be 2, L is 10 centimeters, plus B is 5 centimeters. Therefore, this would be 2. 10 plus 5 would be multiplied by 15, centimeter plus centimeters. So this would be 30 centimeters. That would be the perimeter of that rectangle, meaning that would be the distance around the rectangle. That goes for a square. A square would have both sides equal. So this would be L, and that would also be L. And this is how the formula of the perimeter for a square comes about in your textbook, which I think I've provided. If you go down again, you'll see that, rather in your learning guide. So perimeter again for a square would be equal to L plus L plus L plus L. This really gives us 4L. Therefore, if it was the same, if this was 10 centimeters, that would mean, because it's a square, this would also be equal to 10 centimeters. So this would be 4 multiplied by 10 centimeters, which would be equal to 40 centimeters. So that's that really about perimeter. So it's the distance around, and we can find the perimeter for regular shapes and as well as irregular shapes. So one of the questions that you might find in the test that you might be asked is explain to a child how they can find a perimeter of an irregular shape. And you should be able to do that. So the next part then we're going to move to is finding area. We have attempted to provide you again the definition of area. Why it's important for you to know definition is because you are going to teach these terms to your children, and your children need to know what it is that you're talking about. So area really is the space any flat surface occupies. That would be the area. Any space that it occupies is its area. So that is for a regular shape. An irregular shape, or we can also find an irregular shape like that, and the space it occupies would be its area. So we can see that this particular irregular shape is enclosed by that perimeter, and this is the area it occupies here. A regular shape like this one, which is rectangular, is enclosed again by that, and the area is the space it occupies. That would be its area. So let us very quickly then look at regular. This is regular. Let me change the color again. Go to our normal color. So this is our regular, and this is our irregular shape. So let's see how we find area of an irregular shape, and this is how you ought to explain it to your children. Now we have our irregular shape that is, say, like that, and its area therefore would be the whole of that. Now for us to find the area of an irregular shape, you ought to divide this shape into what we regard as square units. Square units. So square units, that means it's 1 unit by 1 unit. That's why it's a square unit. So if that is 1 unit, this would be 1 unit. So you divide it into all these square units. So let us say we had all those square units like that, like that. So the first thing we'd do would be to count the complete square units. So you'd count, say, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 27, 28, 29, 30, 31, 32, 33, 34. So those are complete square units. Then the incomplete ones now, this is complete, so that would be 35. The incomplete ones, we combine them. So we'd say this one and this one makes another. And that part and that part makes another. That part and that part makes another. So that's almost 38. That and that, almost 39. That and that, 40. That and maybe part of that is 41. That and that, 42. This may be, and part of that is 43. That is complete, 45. This part and that, 46. So we would say approximately 46 square units. Because it's an irregular, our findings will not be so precise. There will be approximations, really. So this would be 46 square units. But the point here is this is how you teach your children how to find the area of an irregular shape. They ought to divide that part into square units and then count how many square units there are. And those that are not complete, they combine them. And they're going to have an approximate. With children, you might not, they will have different answers. So some might find 48, others 47, others 45, which you will accept because it's an approximation. That's for irregular shapes, and that's how you find the area of irregular shapes, by dividing it into various square units and counting the number of square units. Then, again, we are saying square units. The reason being, it was a unit multiplied by a unit, which gives you, if this is one unit and that's another unit, that's what gives us the square units, which is not the same as if we were just finding perimeter, because it's just a length around it. So it would not be in square units, but it would just be in units. Now, for a regular shape then, for a rectangle, for instance, which has the length and the breadth, again, area, this is very rudimental, very, very rudimental. I expect all of you to know this. Area would be length times breadth, and we should be able to find the area of that quite easily. So it will be L times B, again, square units. Why am I calling them units? Because we have not specified what they are. This could be, if they were centimeters, it would be square centimeters. If they were meters, it would be square meters. But in mathematics, when the units are not specified, we just call them units. Okay? So that's why I'm saying square units. But if it was centimeters, it would have been square centimeters, because it would be centimeter multiplied by centimeter, length times breadth. So it would be centimeter times centimeter, would have been square centimeters. I hope that's okay. So then for a square then, where this is L and L, area would be equal to length times length, which is L squared unit. Square unit. Length squared should be square units. So that's what it would be. Now, the part that I'm interested in now, as it gets more interesting, is a circle. Now, for a circle, the length around it is a circumference. We have discussed this. Circumference. And the distance from the center of the circle to the circumference is the radius, small r. And the distance through the center of the circle to the other end of the circle is the diameter. Diameter. Diameter, which is 2r, because it's 1r plus another r, that is our diameter. So the circumference of the circle would be the distance around the circle, which is really the same as the perimeter around the circle. But in terms of a circle, the perimeter has a name, which is circumference. Circumference is given by 2 pi r. This is a formula that we ought to know. Pi is a constant. It is a constant, and it is usually provided as, in mathematics, as 22/7. So we must just know that it is a constant, which is 22/7. So the circumference, therefore, is given by 2 multiplied by pi multiplied by r. Now, if you look carefully, this 2r is in actual fact remember our diameter was equal to 2r. 2r. Therefore, this can also be, instead of 2 pi r, it can be pi d, because d is our diameter, which is equal to 2r. That. So circumference of a circle is either 2 pi r or pi multiplied by diameter. So we ought to remember that. It's either 2 pi r or pi times diameter. Excuse me. So we need to know that, and therefore I expect you to try a few exercises. I've gone up to page 65, but the one part that I've left out is that of a triangle. Area of a triangle. Now, area of a triangle is given by, if you look at a triangle, in actual fact, is given by A is equal to half the base multiplied by the height. Half the base multiplied by the height. But if you look at it, this would be the base, and that is the height. But why do we say half the base multiplied by the height? Because if you look, the triangle was actually formed from our rectangle. Okay? And our area of a rectangle was L times B, but half of it would be what? Would be half of that, isn't it? So that's how we get our half base times height. So the formula really is derived from the formula of the area of a rectangle. Again, try and show that to your children so that they're able to relate and see how the formula for area of a triangle relates to the formula for area of a full rectangle, which is L times B. But here we are referring to a right-angled triangle. Okay, so then we can also find area of a non-right-angled triangle as long as we know its perpendicular height and we know the base. So we can find the area of this triangle by knowing, as long as we know its height and the base. So area again here would be equal to half the base multiplied by the height. The base would be B, which would be that, multiplied by the perpendicular height. The height again must always be 90 degrees to the base. The perpendicular height would be H, like that. So if we're told the base from there to there was 20 centimeters, and the height was, say, 10 centimeters. Look at this. We are not only looking at this distance here, which might be maybe 8, or let's say 11, but we are taking the base as the whole of that, which is 20 centimeters. So area of that would be half multiplied by the base, which would be 20 centimeters, multiplied by the height, which would be 10 centimeters. Now, if we were to use this, the area that we'd be finding would only be the area of that, which would be correct. It would mean we need to know, to find the area of the whole of that, we would also need to know this length here, so that the height is still the same, so that we can use that height, which is the same, to find that area. So there's nothing wrong with you finding the area of that plus the area of that, as long as you know that length and that length. So that would be the base for you to find the area of that, and that would be the length for you to find the area of that. You add the two areas. But in mathematics, we always strive for the best way to find an answer to a problem. So if we know the base and the height, why must we find the two areas and add them? Why don't we just find the area of the whole triangle at once, which would be half the base that we know to be 20 centimeters multiplied by the height that we know to be 10 centimeters. And that would give us the area of the whole of that. So always give different scenarios to your children so that they're able to understand what you mean by area and explain it that way. So I have therefore looked at area of a rectangle, area of a square, and we have looked at area of a circle. No, we haven't looked at area of a circle yet. We have. If we go back, I think we've looked at circumference. Yes, we've looked at circumference, but we have not looked at area. So we'll go back to area of a circle. Good. So here we are. So the area of a circle, therefore, would be what we are going to look at now, which would be area of a circle. We need, again, to know its radius. We cannot find the area of a circle without its radius. So we must know the radius. So the formula for area of a circle, which means that the space it occupies. Remember our definition of area. The space the circle occupies on the flat surface. Now, area of a circle is given by pi r squared. Our pi, we know pi to be a constant equal to 22/7. Our radius we might have been given from there to there to be maybe also say 7 centimeters. So area of this circle, therefore, which is equal to, always try and rewrite your formula. It always helps you to remember what you are dealing with, and emphasize that to your children as well. So area of a circle, therefore, will be, we substitute our pi, which is 22/7, multiplied by, what is the radius? It is 7 centimeters. Multiplied by, because it's not twice the radius, but square the radius. So the radius is being multiplied twice, multiplied by 7 centimeters. So centimeters times centimeters will be centimeters squared. So the area, therefore, will be equal to 22/7 multiplied by 7. 7 here is 1, 7 there is 1. Centimeter multiplied by 7. So therefore it will be 22 multiplied by 7. So which will be 14 plus 1, 154 centimeters squared. 154 centimeters squared would be the area of this particular circle. I think let's end this lecture here today, and if you got your learning guide now, there are activity 4A, activity 4A on page, activity 4A on page 66. That's what I would like you to do. So try that. Have a good day. I hope to see you again or hear from you soon. If you have any problems, please do get in touch with me. Thank you. Have a good day.